So I'll introduce Lukaš. Likavčan is a philosopher focused on emerging technologies, ecology, and astronomy. In his work, Lukaš traces intertwined histories of scientific infrastructures, ideas, and cultures mobilized in human efforts to sustain planetary habitability. Previously, Lukaš taught at NYU Shanghai, FAMU in Prague, and at the Stroke Institute in Moscow. And as a visiting researcher, he was based at Leiden Observatory, Earth Life Science Institute at Tokyo Tech, Hong Kong Poly U, and panel on planetary thinking at the University of Gießen. And besides his academic work, Lukaš has also developed interdisciplinary projects in the art system and broader cultural endeavors, such as CERN Arts, KW Berlin, Venice Biennial. At the moment, Lukaš is teaching at the MA in Information Design at the Design Academy in Eindhoven. There's a lot of very interesting stuff going on. And at the MA in Natural Environments at Central St Martin's in London, where he's responsible for co-curating an R&D platform, EarthZooms. So with that, I'm going to hand over to Lukaš. Thank you.
Thank you, Suhail. Thank you so much for introducing me a little bit. And thank you so much to everyone who arrived today to see this video lecture. I just want to check, did you hear me well in the right here? Okay, so since I can't really hear that much about what's going on in terms of like the spatial distribution of the sound, I just wanted to make sure that you can all hear me well. So thank you, Suhail, for introducing me, and thank you also, Red, for helping with all the technicalities around this lecture. It's an honor to be again at Goldsmiths. Last time I was here, I was visiting the seminar room of the Center for Research Architecture when Susan Shupri invited me to talk about, let's say, some of the more methodological questions related to visuality of climate emergency, but also visuality of space observation and astronomy. And so, as Suhail already introduced me, I'm a philosopher that has kind of like three main domains of interest. It's emerging technologies, ecology, and astronomy. So if you will, I often oscillate between, let's say, like a planetary and extra-planetary context of thought or context of thinking, because there is something like a tagline or like a motto for my research. It's been always, since basically doing my PhD, it was always about rethinking ecology outside, without, beyond, or after nature. And so currently, a part of my teaching duties, which are primarily at Design Academy Eindhoven, but I have this little gig at UAL, Central St Martin's, which means that I'm there like, I was there last February, I will very probably be there next February to teach a little bit about the project which is related to the wearables space infrastructure, the way how we can, let's say, use some of the technologies that were originally developed in the context of outer space exploration to treat climate mitigation and adaptation efforts here on Earth. So that's the project EarthZooms that I work with that I work on with Stephanie Sherman and Rachel Bell, who are based at CSM. I'm also currently a researcher at the Institute of Philosophy at Slovak Academy of Sciences, which is something very important for me because I'm from Slovakia, and for the first time in my life, I'm actually affiliated with the Slovak institution, so it feels really good. And I'm also part of this think tank, or let's say speculative thinking program called Anti-Gitra, which is currently incubated by Berggruen Institute. I'm going to talk a little bit about some of the articles that I recently published with Anti-Gitra also in this lecture. But let me rewind first back to 2019, when Strelka Institute, no longer existing Strelka Institute, published this little purple book, which is called Introduction to Comparative Planetology. Maybe some of you encountered this book in the past. It's a kind of book that is pretty dense in a certain way. It's something like an opening for a certain research program, an opening that I've been sort of like elaborating on for the last couple of years. So in this book, I kind of try to, let's say, look at different visual and philosophical cultures of imagining our planet, the Earth, and I was kind of going back to the, let's say, tracing what we can mean, what we can understand by the geo of the geopolitics, the geo of the geopolitical, how different ways have we segment the Earth, and the Earth's surface in particular, according to different principles of political sovereignty, how these kinds of segmentations and subgroups result literally in different versions of the Earth's geology, ecology, biogeochemistry. A follow-up to this book wasn't another book, it was rather a collaborative project, which I embarked on with an Amsterdam-based NGO. The name of the NGO is Bach Future Lab. And this project was called Northern Planets. So what we did here is that we kind of used the medium of this project to take the ideas of this book further by actually applying it in sort of like real-world implementations. One of the outputs of this project was an atlas, which is called Northern Planet Atlas. And for that purpose, I assembled a working group with some other scholars that were sort of at the same generation. Let's say people that I already collaborated with before. It was Solveig Čusius, Klára Pelošková, Chris Julian, and especially Adonis Bobo, who's London-based, no longer practicing academic, but one of his legacies is a beautiful essay in this atlas that I would really encourage you to read. And when it comes to geopolitics, I mentioned geopolitics. I think that lately my efforts leaned a lot towards this project, which I co-edited with a Chinese sci-fi author whose name is Stanley Chiu-Fan Chen, and with Benjamin Bratton. So this is a kind of collection of essays, or not really an essays, but rather short scenario fictions, as we call it. 18 scenario fictions by 18 authors that explore future of multipolar geopolitics and the way how, I would say, computation and governance increasingly become one and the same thing. We have also Suhail in it. He has a scenario there, and I will also encourage you to read the scenario, since it's kind of about finance, economics. It's a really interesting take on the future of insurance industry as well, because all of these scenarios are looking at the, let's say, near-term to mid-term future of multipolar geopolitics of computation. And it's out now with, our journal, a journal called Embedding Journal, which is published by MIT Press. So you can have a look at this collection of essays and scenarios, especially if you're interested in, let's say, how we can do, let's say, projections and a certain kind of, I would say, foresight analysis from the perspective of more speculative practices, let's say. After introduction to comparative planetology, my next step was also to look at exoplanets. At least that was kind of the my way how to realize that I cannot simply look only at one planet, the Earth, but I should actually look at planets in some kind of like larger perspective. So I look at exoplanets, which means exoplanets outside of our solar system, and also I look at other planets in our solar system, hence kind of removing a certain kind of Earth-centric bias in thinking about ecology. Because it is very likely that every single star that we look, but when we look at the night sky, every single star probably harbors a planet, some kind of solar system with one or multiple planets. And it's very likely that some of these planets are similar to Earth, but also there can be like so many new strange worlds, so many other kinds of planets with biospheres and technospheres unlike anything that we have actually on Earth. And this realization sent me on a kind of writing streak that slowly comes to its fruition these days. So one of the things that I wrote is this paper that laid foundation to this journey. I wrote it during my time at the observatory in Leiden, in the Netherlands. And what I did here is that I basically translated an astronomical definition of a planet to a kind of philosophical concept of a planet. But before I unpack this concept, I want to talk first a little bit about my methodology and also about some of my basic assumptions as a philosopher. So, consider that most of the astronomy would be impossible without mirrors. And when it comes to mirrors, we can think about like high-end like technologies that we have today, such as, for example, James Webb telescope. But actually, we can trace the history of telescopes, optics, mirrors, and the use of all these devices in astronomy to the inventions of Muslim astronomers in like 9th or 10th century. So there is a long, deep history of optics and mirrors in astronomy. In the early modern era, these mirrors or these different optical devices were further, I would say, perfected. There used to be the kind of telescopes which were called refractors. Those were telescopes that were used to kind of like see the first, for example, for the first time see, for example, the moons of Jupiter, or see the first moons of, for the first time see the moons of Saturn. And later, these kinds of telescopes were replaced by more, let's say, advanced telescopes, which were using mirrors to actually reflect light and magnify in a certain way the images in the way that were really unprecedented before. So there is a certain technical, methodological, epistemological side to mirrors in astronomy. It's an important observational tool. But on the other hand, there is also a certain metaphorical sense of mirroring that I would like to point at in relationship to any kind of outer space research. There's a kind of mirroring of cultural imagination, if you will. We see some certain analogies between the terrestrial and the extraterrestrial. Lisa Messeri, she talks about gestures of cosmic relation. And this is the kind of citation that I really tend to overuse a lot in my recent writings, since I kind of really adore it, because it gestures at the ecological relevance of astronomy that I am also so interested in tracing, of course. So she claims, astronomy does not stand apart from terrestrial pursuits, but rather deeply informs understandings about Earth and our modes of being in the world. The quest to find a planet like our own, as with human spaceflight, promises greater understanding of places elsewhere in the universe, but also provides a mirror for examining terrestrial relations. There is, however, also a certain kind of flip side of mirrors that I would like to point at, because this relation of mirroring is on the one hand, of course, an extremely potent philosophical metaphor to play with, but there are many ways how astronomy works as a mirror of terrestrial affairs in the, let's say, worst possible sense. And this is happening especially today. Outer space exploration is many times rightfully criticized as projection of a certain kind of white, Western, masculine colonial chauvinism. But this is no big news. If you look at, for example, Solaris, the famous novel by Lamb from 1961, Stanislaw Lem. At one of the chapters, he confronts us with a certain critique which culminates in this resigned proclamation of one of the main protagonists of Solaris, that we don't need other words, we need mirrors. And the novel really criticizes this kind of human colonization of outer space as subservient to the urge to project into the cosmic outside the biased human preconceptions. Hence, my motivation is to escape this mirror game, to learn to see ourselves through unfamiliar eyes, just as actually Professor Stjernhal sort of instructs us to do on that citation that is at the entrance to this lecture. So, what's the kind of optics related to this unfamiliar, like seeing through the unfamiliar eyes? It's a kind of optics that begins with the extra-planetary first. The motto here is that there is no planetary without the extra-planetary, no ecology without cosmic perspective. And me as a philosopher, I find something compelling about all these mirrors and optics related metaphors in astronomy. Because if you think about philosophy, it's a reflective activity, an activity of some form of contemplation and mediation. After all, optics was one of the favorite disciplines of early modern Western philosophers too. René Descartes, for example, or Thomas Hobbes, wrote significant volumes on the issues of bending and reflecting light. Baruch Spinoza was a lens grinder. And another philosopher, Gottfried Wilhelm Leibniz, placed optical metaphors at the center of his metaphysics. So there is always some kind of like a metaphorical invocation of mirrors, especially in early modern Western philosophy, but not only there. If you look, for example, into Buddhism, and especially Mahayana Buddhism, it's full of optical metaphors as well. You find for example, analogies or different descriptions of cognition as a certain kind of intellectual vision, an ability to see in a certain way, an ability to filter the world in a certain way. What is also very interesting here that mirrors are often invoked in relationship to how to think about self and subjectivity. For example, a Platform Sutra of the Sixth Patriarch talks about Buddha nature as a bright and pure mirror. And what this points at is that, in a certain sense, all these invocations of mirroring and optics, they point at certain epistemic practices that are building subjects, that are sort of built through the rehearsal of a certain observational practice, practices of vision, practices of seeing, practices of mirroring and reflecting. You can look at the history of scientific objectivity, also as a certain work of mirroring here. Dustin and Allison in the book Objectivity talk about exactly different epistemic practices that at the same time not only make objects of science, but also subjects of science, people that see in a certain way. You can look at history of Christian mysticism, Simone Weil, and the way how she's talking about passivity in observation as a certain practice of patient reflecting of the world and self. And this all simply goes into this one major conclusion that I want to discuss with you today a little bit more, which is that I imagine natural sciences, and in my case especially astronomy, as an aesthetic education, as a kind of training of specific aesthetic sensibilities. And while doing so, I'm really trying to transport the notion of the aesthetics back to the 19th century notion of aesthetics, denoting an art of perception in general, of sensing at large, not just a kind of theory of beauty or theory of perception of artistic forms. So there is a hidden agenda behind this framing of astronomy as an aesthetic education, actually. Because if you look at it, I believe that astronomy is a training ground for ecological thinking. The sensibilities astronomy cultivates can be hijacked to reinforce ecological sensibilities in dealing with our own terrestrial affairs. So in the last instance, I argue for deep alliance between epistemic practices that are native to astronomy and ecology, because after all, as I already mentioned, there is no planetary without the extra-planetary. So now a question. What is a night sky full of stars? To me, every night we look at the stars, we are looking at a distant past. The starlight that we see have traveled thousands of years to reach our Earth. And what we see here is an archival image of the universe once upon a time. It's a natural photography of sorts, or even a photography of photography in a certain way. So this brings me to the understanding of, let's say, the image of the universe as a kind of image of the first archive. And the starlight here is something like a messenger of this first archive in this sense. An archive that stores information about the cosmic events spanning almost the entire history of the universe. Now, I have a question for you, and I really want to open up a little bit earlier for this part of the lecture, because I want to ask you, what do you find interesting about this image? What are the things on this image that strike you as somehow unnatural or something that shouldn't be there, for example? What is about it? Is there something disturbing about this image, for example, or something that is suspiciously compelling, I would say, about this image?
It's not AI.
Sorry?
It's not AI.
It's not AI. No. There was someone over there.
The colors?
Yes, the colors. Why?
Just that they've probably edited different wavelengths of light to get those colors.
Yeah. There are actually two interesting things about the color here, because the first thing is that the color is used as a coding for the distance of the object. The more towards the red, the more distant. The more towards the blue or white, the closer is the given object. But then we have the second layer here, which is this kind of like a dramatic situation happening in the foreground of the image, which is basically the birth of the binary star system. And here there is a different information coded in the colors, because it is about the temperature of the gases. So there is kind of like an interesting clash between like two aesthetic regimes, or like the two ways how color codes certain information here. What about other aspects? Let's say more geometrical?
Yeah, the shape of the light kind of refract.
Yeah. Do you know why?
Is it not the lens?
Yes. Yeah, the lenses are hexagonal. So you basically see an imprint of the infrastructure in the image itself. And in this sense, like an astronomical image is a perfect example of an image that in a certain way, not really, explicitly, but there's a certain kind of honesty about the infrastructure which makes that image. In a certain sense, you can analyze the infrastructure of image making through looking at the image, which I guess is something that at visual arts in general must be like a kind of analysis that you are all encouraged to do.
Do you mean like you close the exposure to make certain things visible and not overexposed?
With exposure, it's actually, these are very, very long exposure times.
Yeah.
It's like tens of hours, basically, of continuous capturing of light to make an image like this. So in a certain way, also what is interesting is that actually this image is made of like thousands of other images that are kind of like stacked on each other to produce the resulting, level of brightness of the image in this particular sense. Anything else? Yes, please.
I'd say the scale.
The scale.
Yeah, just how large that is.
There is probably a certain strategy in the way how the image is,
in comparison to all of the stars and planets, it's a massive phenomenon.
Yeah. Maybe it even relates to the previous point about the exposure, because there are some objects that can be sort of like a good reference point for magnifying the scale of the things that are happening in the foreground. So to kind of like really emphasize the drama of the birth of the binary star system. The other object should be like more like silent witnesses in the background, rather than another like occurrence that would somehow disrupt the observation of the resulting image. Yeah. Please.
Two things. There's a clear boundary between colors, and then
Yeah.
how identical the stars are. Like these two are super identical.
You mean, for example, this one and this one?
Yeah.
Yeah. What does it say? What does it tell us?
I don't know. Obviously these two stars are not identical at all. I guess
Yeah,
in reality,
yeah.
they are in a photo.
That's a certain, let's say, disadvantage of distance, but also disadvantage of, let's say, a purely, let's say, the representation of the universe in the visible spectrum of light is a certain kind of unwelcome informational reduction. If we would be able to look at it in the infrared, actually this image was originally taken in infrared, but then it was rendered for the eyes of the human observers in the visible spectrum. In the infrared, we would be able to see the gaps and peaks in the emission and the absorption spectra, so that we could actually tell, for example, what's the composition of the star in terms of the gases that the star is made up from. So you're right that in a certain sense, these stars look identical for us and for everyone who is going to look at this image in the visible spectrum, but they may be radically different. They even may be, probably distance will be similar, given the brightness is similar, but you're surely right about this point on the stars being so dissimilar in many important ways. So this is something like a visual exercise, and it's also an exercise through which I want to onboard you a little bit more on how I actually do philosophy of astronomy. That there's a lot of aesthetics involved, there's a lot of analysis of, let's say, these metaphorical transitions between different domains of analysis, different domains of like knowledge making. Sometimes I hijack astronomical vocabulary just to talk about ecology or to talk about technology. And I think this is an important takeaway to keep in mind as I progress further in this lecture. Are there any more questions now? Because if not, I want to talk a little bit more about the astronomical concept of the planet that I have very briefly mentioned before, that I have written a paper about the astronomical concept of the planet. So, let me know first that this kind of pivot towards exoplanets is pretty much in line with how comparative planetology has been really understood by the progenitors of this discipline. This citation, for example, I didn't know this citation back then when I was writing Introduction to Comparative Planetology. Perhaps it would be another book if I would read George Gamow first. So George Gamow, in the biography of Earth from 1948, he mentions that comparative planetology is something that we can think of in analogy with anatomy. Anatomy, for example, gives biologists a better understanding of the human organism by comparing it with those of mosquitoes and elephants. Let's say that by comparing different biological organisms, you can find something that all these organisms share in an important way. For example, a certain basic, let's say, biogeochemical substrate from which the given organisms arise, such as DNA, for example. And the implication to me, in the cosmic sense, is that, again, only like through this cosmic perspective we can understand ecology and sustainability, because in order to understand what is the planet to care for, we need to understand what is the planet in general. The astronomical concept of the planet that I've been working on renders the planet as something that is layered, something that is a process, something that is a historical entity, and also something that is exposed to the expanded ecology of the solar system. So, saying this now, for later, I'm going to unpack this right away. I'll start with the point 1 and 2. That the planet is layered, and that it is a process. What kind of process is a planet? With Adam Frank, an astronomer, astrophysicist, astrobiologist from the University of Rochester, I recently written an article where we are trying to argue that the planet, or any planet, is a metabolism. Every planet is a metabolism to the extent to which it is a dynamic entity, that constantly negotiates the relationship to its outside. So the planet can be seen as something like a generic space of manifold exchanges. When Gary was talking about exchange and economy, I think this is like the good analogy to think with, that the economy, as we know it, is but a tiny, tiny part of the general economy of the planetary metabolism. You can see it here in this, on this table, because if you look at the total, let's say, energetic input that the planet gets from its solar system environment, especially the sun, and you compare it to like the anthropospheric processes, which are basically all the processes of the human economy, you see what kind of fraction, a tiny part of total planetary metabolism, the human metabolism at large is, if you will. Moreover, the planet, understood as a metabolism, comes with a particular spatial form. The spatial form is a sphere, and it is organized into layers. I've already briefly mentioned, such as atmosphere, lithosphere, inner core, and we can think about these layers as some kinds of phase gradients, if you will, meaning that they represent different states of matter, such as gas, liquid, ice, solid, metals. This diagram nicely illustrates that, if you look at it, and it also points at the fact that composition of the planet itself diagrams, to some degrees, the metabolic flows. So the metabolism, as it spatially unfolds, in a certain way, copies or sort of like diagrams, as I say, the process that it is. It's something like, for example, in the visual or design studies context, Dietmar Offenhuber, a design researcher, he calls this autographic visualization. There is a certain like a self-inscribing property to the given process. Now, let's move to the point 3 and 4. That planets are historical entities that are exposed to the expanded ecology of the solar system. The first thing to note here is that planets are linked to in the evolutionary history of solar system. As Stephen Soter puts it, planets occur only in highly evolved, old systems which have reached the final cleanup phase of accretion with the major bodies in stable orbits. Planets are thus symptoms of a particular stage of the evolution of the given solar system. And to understand this better, let me introduce you the big picture of the solar system's evolution, which you can also see on the video on this slide. There are 3 stages of formation of solar system. They are called primary, secondary, and tertiary accretion. So in the primary accretion stage, that's basically the stage when the sun itself forms from the nebula of gas that collapses and creates this hot ball that we call the star. But there is some, let's say, there are some remnants around the star. The sort of like the remaining disk which begins to spin around the star. And this spinning disk, inside this spinning disk, you get these like tiny, let's say, nodes or like tiny pieces of matter that are called planetesimals. And from these planetesimals, bigger objects can assemble, and that's what we call planets. That's the secondary accretion, the creation of the planets. And the tertiary accretion then is what's going to happen with all the remnants from the secondary accretion. You get moons, comets, asteroids, and that's kind of like the cascade of the way how the matter folds itself into these different structures. It's a certain kind of, it's a process of sculpting of a certain kind of like gravitational architecture that's going on here. Again, a brief checking. Should I unpack this more? Would you like to hear a little bit more? Because there's like a couple of slides now that are going to be like really heavy metal astronomy.
Yeah.
So
I want to hear about
Yeah.
the tertiary.
Sorry?
The third one, tertiary? Is it
tertiary. So the primary, secondary, and tertiary accretion.
Yeah.
You have a question about the tertiary.
Yeah, what does that stand for?
So imagine that my fist is the sun. Around this fist, there is a disk that is spinning. That's the disk that you see also here now on the big screen. And inside this big disk, you have these different like flows of gases that are actually like creating bigger structures. Yeah. Imagine it like something like little snowballs or like granules or something assembling. And these are then creating bigger and bigger objects, and in the end, you have the planets. But then, there is still something remaining. For example, on the disks around the planets. So you think about it really as a cascade. What happened on the scale of the given star, having the disk, now you have planets with little disks around. Yeah? And from that, for example, you get moons. Sometimes like this material is propelled away from those planets. And for example, you get the Kuiper belt, which is at the end of the solar system, which is kind of like a belt of debris, which is around the outer edges of the solar system. That's where comets are born, and then they travel on these like eccentric trajectories to around the sun and back. Does it make sense? It's kind of like
So that's tertiary?
Yeah.
Accretion.
Tertiary accretion is when comets, moons, asteroids
Right.
are born. Yeah. Mhm. So you can, there are no like moons of moons, but in theory, we could go on if the gravity would allow it, but at certain thresholds simply it's not possible to create smaller objects because they don't really stick together at certain scales. Yes?
Why does it stop at the tertiary?
Oh yeah. I mean, there are just physical constraints, which is, for example, given the fact that I think it is around like 1,000 kilometers in diameter. If you get something smaller than 1,000 kilometers in diameter, it's an object that will not be able to be in something which is called hydrostatic equilibrium, which is basically just like a fancy term for sphere.
Okay.
Yeah. So if you have something that is smaller than 1,000 kilometers in diameter, what's going to happen is that it's going to be more like a potato. And the smaller it is, the more kind of like bulky it's going to be. So that's kind of like the under the 1,000 kilometers in diameter, we have asteroids. For example, the biggest asteroid in solar system is called Ceres, and people thought in the 19th century that it's a planet because it is almost sphere.
Okay.
But then people realized that probably this is a remnant of some kind of collision that actually created the asteroid belt between Mars and Jupiter.
Thank you.
Yeah. But gravity is really important in general in thinking about the architecture of the solar system, because gravity, the ability to sort of like clear your neighborhood from debris, is one of the criterions today to consider something to be a planet. That's the reason why Pluto is not a planet anymore, because Pluto was demoted basically on the grounds that there is too much of a space debris, of the remnants of other objects around the neighborhood, in the neighborhood of Pluto. So there's a certain reason for let's say believing also, like for me, that planets are dynamic entities in the sense that they earn the status to be a planet by some active negotiation of their boundaries with the outside. I'll follow up on this a little bit more now. In the interplay of the extraneous forces of the sun and the intrinsic dynamics of the planet, we can observe bootstrapping of multiple feedback loops that wrap up the planet. They turn the planet into an environment with increasing degrees of autonomy from the outer space. And this holds for any planet, not just for Earth. As the planet matures, so to speak, it becomes less and less determined by the outside factors and more governed by the processes of its own making. So it can be argued that the process in which any planet acquires this kind of autonomy from the cosmic context is later rehearsed down the line with the emergence of life on some planets. Why? Because if you think about it, you can say that the planet actively maintains its separation from the cosmic environment, similarly as a cell does actively maintain its separation from its surroundings. Perhaps the planet is the original metabolic template in this sense, an evolutionary predecessor of the living matter. Emergence of life is closely linked to the concept of planetary habitability, and this concept is vividly discussed in contemporary astrobiology and exoplanet research. The standard definition of habitability goes as follows. The planet is habitable if the conditions on the planet enable an evolution and existence of Earth-like life. For any planet, again, not just Earth, it holds that the energy received from the star may dramatically impact what category the given planet belongs to. Also, it impacts whether it can be considered habitable due to the atmosphere, which is the result of the interaction between the solar energy and the planet. The surface temperature of the planet can get way higher than the temperature corresponding to the energy balance between the incoming stellar radiation and the residual heat, which is disposed by the planet back to the cosmic void. In case of Earth, it's actually staggering plus 33 degrees Celsius. So without the atmosphere, the conditions on the surface of the planet would be basically kind of below zero, way below zero, which means that Earth would be basically a deeply frozen brick without the atmospheric envelope. So the atmosphere is a kind of interesting buffer zone here, like a buffer zone of the negotiation between inside and the outside. And in this sense, again, it kind of like prompts me to say that the cosmic ecology precedes the planetary ecology. Now, talking about biosphere a little bit, Jan Spitzer, one molecular chemist and biologist, he says that you cannot replicate origin of life just by mixing right chemical substances together. You actually need a planet and a specific kind of planet, an environment of early Earth, for example, which includes tides that are caused by moon, presence of seawater, right rotation of the planet, the presence of electromagnetic field. An early Earth, if you think about it, was basically something like a hot spinning incubator of life. And such a unique environment is currently quite impossible to artificially reproduce, especially because of the scale. The important conclusion here is that we cannot talk about planet as something that hosts life. We need to talk about planet as something that makes life happen. And it follows that life is a symptom of some major planets, just as planets are symptoms of some major star systems. Needless to say, seen from the cosmic perspective, the planet's habitability is just a phase. It comes and it goes. Some planets have long windows of habitability, such as Earth. Some are very short. Think Mars, with its brief period of surface lakes and seas, the so-called Amazonian period of Mars. Nevertheless, habitability, it remains an interesting concept. In my view, it has direct environmental implications for how to maintain viable inhabitation of a planetary environment. In his recent collection of essays, Dinesh Chakrabarty proposes a maxim, something like a maxim of planetary thinking, a motto of planetary thinking, to keep other planets always in view, even if only implicitly. This maxim suggests to think about planets in kind of generic perspective, and in this view, the planets are treated as objects emerging from the broader context of the evolution and architecture of their home solar systems and their relation to the whole star. Interestingly, Chakrabarty links the maxim to reorientation of global environmental political goals. We should not strive for sustainability of human inhabitation of the planet, but for maintenance and prolongation of the planet's habitability, irrespective of given species. In other words, sustainability is a narrow-minded environmental goal, way too much human-centric, subservient to logic of economic growth. Habitability goes beyond. It is life-centric, it is biosphere-centric, and it looks at the planet from cosmic perspective. But what exactly means to keep a planet habitable? And is habitability really enough? That's an open question for me, and again, an open question for you, because I have one question, whether you want to hear more about asteroids or aliens, but before, I just want to make sure that there are no pressing questions from the audience, like questions of qualification, technical questions, anything that you would like to hear before I move on. But also I can keep going, or should I?
Can you do the habitability, sustainability distinction again?
Yes. I think it's an important distinction in the sense that sustainability, if you, for example, look at the early documents that define sustainability for United Nations or other world government organizations, there is the report. It's called Brundtland Report. I think it's 1972 or something like that. And that's there you find the definition of sustainability that became binding to many, let's say, development plans, for example. So this definition is that sustainability is about preserving or using only so many resources that you don't compromise the possibility of future generations to use those resources as well. So there was an implicit intergenerational framework, which is nice, but again, it is about economic consumption of resources, and it's only about okay, are these resources sustainable or no? What is the life cycle of the given resource? How quick it regenerates? So it's a very narrow window of how do we see the planet? We see the planet as a repository of resources. Okay, those resources are dynamic, they can regenerate, but that's it. So
habitability.
And habitability. Habitability in Chakrabarty hijacks the notion of habitability from the astrobiological to, let's say, the planetary humanities context. Yeah? And what he does is that he says that habitability, it is not about flourishing of a particular species. It's about biosphere at large. It is about well-being of the biosphere, in other words. That's how Chakrabarty looks at it. I have my hesitations about whether habitability is enough, and I will talk about it in a while when we talk about aliens. So the question is really, do you want to hear about aliens or about asteroids? Aliens, asteroids. Okay, I probably need to vote. Can we vote? Asteroids. Aliens. It's going to be aliens, and we can talk about asteroids in a Q&A. Yeah. Okay, so I need to skip some slides now. This was also a convenient way for me when I was flying here in the morning. I was like, how do I make this shorter? And I was like, I'm just going to ask audience whether I can skip some slides by creating this like situation of decision making, of a collective decision making. So, this paper is published, or it's been published last week. It is also in the anti-literary journal that I briefly mentioned. And the name of the paper is a long L. Yeah, I even tried to make like this like funny thing, like I mean it's L, yeah, and it's 4L because Lukaš Likavčan, long L. And the idea of this paper, or the motto of this paper, comes back. I come back like to this citation by Freeman Dyson, that the first law of SETI is that every search for alien civilizations should be planned to give interesting results, even when no aliens are discovered. And because of that, this paper is about Fermi paradox. So how many of you are familiar with Fermi paradox? Can someone explain us what is Fermi paradox? Red, you have a mic, so you can do it.
The paradox speaks about the Great Barrier, and that being one of the reasons why we haven't found other forms of intelligence and life, within the cosmos. Is it because the Great Barrier is ahead of us, civilization like us, and we eventually reach the barrier, we've destroyed ourselves, and that's what's happened to other civilizations, or
you're right. I mean, the concept of the Great Barrier or Great Filter is a concept that is already, let's say, related to solutions of the Fermi paradox. But you also told us basically what the Fermi paradox is, that it is, like, the question is, like, where are they? Why no one visited us so far? And also, like, why we haven't been able to observe any signs of intelligent life when we look up and observe other stars and other planetary systems. Enrico Fermi originally formulated this paradox at one of the lunches in Los Alamos in 1950s. And basically to me, like, I read this Fermi paradox as a sort of mirror again, a mirror of the terrestrial imagination about humanity's own future here on Earth. Because if you think about many solutions to Fermi paradox and also the very idea of the Fermi paradox, it presupposes these like megalomaniac galactic civilizations that are just traveling from planet to planet and star to star, and they colonize planets and all these things. And it's just like very sort of like it's a very problematic assumption that every single planetary community that we can think of will have this like ambition to colonize other planets, to colonize other planetary systems. There is a lot of hidden assumptions in the very formulation of Fermi paradox about economic growth, that it's something that must happen by almost some like force of, or that the economic growth is almost something like a force of nature, that it must happen because there is always this propensity for the planetary community, for example, to extract more and more energy and jump on this ladder of like the developmental scales of civilizations. For example, there is this thing called the Kardashev scale, that you have civilizations that extract all the resources of the planet, then all the resources of the star, then all the resources of the galaxy. And you can hear like there's a certain absurdity, I would say, that to the cultural imagination, that is kind of like, that is the background of the Fermi paradox. But there is another formulation of Fermi paradox, which is formal and at the first glance a little bit more neutral, and it is this equation. Are you familiar with this equation, anyone?
This is art school.
This is art school. But I see at least one person in the audience who's saying that, yes, they are familiar with Drake equation. Can you tell us a little bit about Drake equation, Iris?
I can't remember the exact ones, but basically it's the probability. So it's like a bunch of elements towards the end of which you can calculate the possibilities of alien life, basically, in another planet.
Yes. So it was used as so Frank Drake, who's the author of this equation, he originally formulated this equation to estimate the number of radio communicating planetary communities in our galaxy. And he used several variables or parameters to kind of specify this main unknown number. And we know about some of these parameters, more or less, what can be their value, like the star formation rate in the galaxy, or fraction of stars with planets, or average number of habitable planets per solar system. These are still some reasonable estimates, based on what we know currently about how many exoplanets can be out there, for example. But then suddenly, like, this equation also gets kind of problematic, because what about fraction of habitable planets with life? Well, it depends on how optimistic the given astrobiologist is, for example, going to be about the actual possibility of the origin of life. Like, is it a rare thing that life actually emerges on planets, or is it something that always happens? Yeah, is the fraction of habitable planets with life 1, which means that basically every planet that is habitable will have life, or is it, for example, 0.0001, because it is a very rare occurrence that a certain planet will actually harbor life when it is habitable. So problems multiply as we go on in this equation. Like, what about intelligent life? Like, what are the, let's say, how long did it take on Earth? Just consider how long did it take on Earth for intelligent life to appear. Probably the first were octopi. And that was already like a certain, let's say, like billions of years in the history of the planet. Like the first 2 to 3 billions of years of the history of planet was mostly about microbes and very simple life forms. But their intelligence can be also, in some cases, considered. So again, what does it mean that we should talk about intelligent life in the context of this equation? And this is kind of the moment when this search for extraterrestrial intelligence gets like full philosophical. And this is also the moment which I find important from the perspective of me as a philosopher of astronomy, because that's the moment when I can actually question what kind of philosophical assumptions astronomers make. With this parameter, the fraction of planetary communities with sufficient technological capacities, things get even worse, because again, like, is it guaranteed that every intelligent life form must have technology? And of course, like, we can also ask the big question, what is technology? So again, problems multiply. But at the end of this equation, the last parameter, L, the average communicative lifetime of the technological planetary communities, is probably the most exciting one, parameter or variable, at least to me. Because to talk about average lifetimes means to talk about societies, about their histories, cultures, economies. And my belief is that the longevity of planetary communities has a lot to do with maintaining the planet habitable, of course. And this brings me to the key question: how long do we want the L of our planetary community to be? Or even better, what shall we do to make the L intentionally longer? The answer I want to discuss starts with this quotation by Carl Schroeder. who is a Canadian sci-fi author, who said that it's a variation on the famous quotation by Arthur C. Clarke that every or any sufficiently advanced technology is indistinguishable from magic, but Schroeder says that any sufficiently advanced technology is actually indistinguishable from nature. In the context of solutions to Fermi paradox, it means that basically every night we look up on the night sky, the stars mirror back to us an instruction about navigating possible futures here on Earth. Because the cosmic silence, the fact that the universe is full of stars and we yet haven't actually encountered any form of intelligent life elsewhere, this cosmic silence is perhaps the silence of flourishing planetary communities hiding in the plain sight, just because they're actually indistinguishable from the background that we are looking at. Now, bear with me. The long L, the question of maintaining habitability, has very obviously a lot to do with ecology. And in his General Morphology of Organisms from 1866, Ernst Haeckel provided us with the first definition of ecology. He described it as the entire science of the relationships of the organism to the surrounding external world. More than 150 years later, we learned a lot about the relationships between organisms and environments, to the extent that we can replicate and apply the principles of environmental relations to entirely new domains. There is, for example, a long history of swarm robotics, which has been originally inspired by collective behavior in ant colonies or beehives. There is this wonderful story, a story that I return to also quite often in my recent writings. It's a story about a Japanese robot whose name was Gakuten Soku, and it was built in Osaka in 1920s by a biologist, Makoto Nishimura. And the robot got suddenly lost and never found again, but it really existed. We have pictures of Gakuten Soku. And the story of Gakuten Soku reminds us how often this technological innovation driven by the desire to mirror the more than human, not the human, more than human. And the name of the robot, Gakuten Soku, translates to English as learning from laws of nature. And Nishimura constructed it with the ambition to embody the capacity to know the world and act in accordance with this knowledge, and also propagate or carry this knowledge forward. And for this reason, Gakuten Soku wasn't a robot meant to do some hard manual labor. It was a robot which was meant to write spiritual texts. And I think that's a really refreshing technological imagination. The idea I'm getting to here is basically this one. To understand these two, biology and technology, and hence by and large, to understand the question of habitability as an alignment of the biosphere and technosphere, we need a kind of generic vantage point of outer space. And the motto here is that ecology is applied astronomy, and so if, as Haeckel says, ecology is the entire, and I really want to underscore the entire science of relationships between organisms and the environment, there is never going to be a planetary thinking without cosmic thinking to start with. And that brings me to the end of my brief, or not brief, but at the end of my contribution. Because in long L, I work with the Drake equation, I work with the Fermi paradox, in order to arrive at a point where I can unpack a theory that would really articulate outer space biology and technology under one umbrella. I call it substrate-agnostic ecology, which is a kind of theory of agent-environment relationships that neglects historically random metaphysical divisions that we all know very well. You know, life, non-life, planet, outer space, technology, biology. And this kind of brings me to the last checkpoint in my talk, the kind of last question space. Before I will jump into last 3 slides, which are going to be about the concept of the careful technosphere that Sunil was originally asking me to sort of like pivot to or kind of like introduce at the end of my lecture. But I would like to open up again a little bit before we move to that concluding part.
that, you had
Yes.
that phrase that was in the middle, substrate-agnostic.
Agnostic. Yes.
Could you just unpack that a
Mhm.
bit, like what the agnostic is doing in there?
The agnostic is, I would use one metaphorical and one more like literal, like grounded, descriptive way how to approach the concept of agnosticism here. The more grounded one is, let's say that in computation theory, you have the idea of substrate independence, which means that a given computational process will run in the very same way, no matter on what kind of computer it is going to run. Whether it is a steam engine powered differential engine of Ada Lovelace and Charles Babbage, or whether it is vacuum tube computer of like 1940s or 1950s, or whether it is contemporary digital computer, those are three different substrates, but you can use the same algorithm in principle to run on each of them. And that's also the general idea of the Turing machine in the sense that it is still a machine that is imagined as a, let's say, reader of the tape that is infinitely long. But still, I mean, there is a certain idea that in principle, the same action can be reproduced on other substrates, meaning other kinds of like devices, literally speaking. But the substrate can be also, in a certain way, or I mean, I am not completely buying this idea, but some people say that, for example, DNA is Turing machine. And because they see a little bit of like a visual reference here, that you have the RNA head, which is reading the tape, which is the DNA. So there is the kind of like analogy between the Turing machine and the DNA that is also possible to construct. And then you can say that, yeah, it's just another substrate that also computes in some way. So this is the agnosticism in its context from which I'm taking this, the idea of substrate independence in theory of computation. But then there is another, I would say more like normatively later concept of agnosticism, which is really about withholding judgment, I would say. There is a certain principle of withholding judgment here. That you are not judging too harshly or too quickly, like, is this living, is this non-living? I think there is an important ethical consequence that I want to unpack in the last part that is related to the idea of agnosticism. I see that you're also really to say something.
Yes. A lot of this, like we're thinking of as like extraterrestrial life, is like based very much on, I don't know if you call it like anthropocentric or zoocentric or something, but it's like based on like what we can see as human, as like a mirror of human life, or I'm sorry, of Earth life, whether it's like microbes or us.
Yes.
But what if like intelligent life or life is something that we don't have a point of reference for, and more just like an energy or an entity that we have no point of reference for?
I mean, that's exactly the point of substrate agnosticism here, that let's not judge like whether it's life living or non-living. Let's, for example, take it as living just for the sake of some ethical argument to be made. I want to make this argument now about technologies, that they are legitimate ecological actors and that they should be treated with a certain kind of care, as I call it, care for technosphere. Yeah. So one of the consequences of substrate-agnostic ecology is that in principle, a community of humanoid robots in a training factory and a community of manual workers in an actual factory are functional equivalents at a much more granular level than one would be ready to admit. The major consequence of substrate-agnostic ecology is also that technological agents are in principle worth of the same kind of care as those agents deemed to be more natural in a folk metaphysical framework. And this immediately suggests that there is an ethical depth in the making towards non-humans. Just consider how across the earth, machines of different species take over duties of care related to human life. From mundane domestic tasks such as vacuum cleaning to less trivial operations such as surgeries or therapeutic consulting. Humanoid robotics gains traction. And in the decades to come, the rapidly aging global population may find itself interacting more with machines than humans, just because there simply won't be enough people in productive age to take care of the seniors. In turn, some people would surely agree the things we make require our care too, and that they may pay us back proportionally to the care we invest in them. Meanwhile, the wave of breakthroughs in artificial intelligence prompted many scholars to pay better attention to the status of technological objects in human cultural and moral frameworks. However, the technical objects usually raise ethical concerns only insofar as they present a possible threat to human integrity. Consequently, the remedy to the pathologies of cohabitation between machines and humans lies in many propositions of AI ethics in strengthening their alignment with anthropomorphic values. Much less often, one hears about how the increasingly autonomous technologies may challenge these established values, for better or worse, or even the basic assumptions about what counts as morality and agency. Even if the moral agency of machines is recognized, it is tightly linked to the traits, features, that make them indistinguishable from humans, such as the presence of recognizable emotions, intentions, and moral reasoning. And in the most extreme case, investment into care for AI agents is even pitted against environmental care as a kind of moral hindrance. Against the grain of these assumptions, I would like to probe the philosophical consequences of thinking about technologies as the offspring of the biosphere, that is, offspring of life as a planetary phenomenon, stretching way beyond the confines of humanity, both in space and in time. The value of the technosphere is a link to the biosphere it belongs to, just as the biosphere is a link to the planet it belongs to. And this translates into the duty of care imposed upon humans as agents within the planetary biosphere. Humans are called upon by the Earth, but this calling is the exact opposite of the technoskepticism so widespread in contemporary critical humanities. So if again, any sufficiently advanced technology is indistinguishable from nature, it follows that the evolving technosphere shall not be pitted against the biosphere as some kind of suffocating blanket, but as vital, reliable, valuable, and even indispensable complement. And that's my conclusion. Thank you so much.
I've just put up some QR codes for Lukasz's articles. If you want to follow up, you can just access them by taking some scans of those. So thank you. That was a lot. It's like the entire history of the cosmos to Boston Dynamics. And also thank you for the approach, because I think it was, I'm really struck by the pedagogic care, because it's a lot of material and you're kind of moving from quite straightforward assumptions about what machines are, what humans are, to like quite an advanced level of changing kind of basic understanding of ethics, right? And then like ethics not just between humans, but planetary ethics, if not cosmological ethics, and this is in relation to machines. And that's a lot to do in an hour. And you did it really well, so I'm kind of I'm impressed and taking notes on how to do it. But in terms of, I'm sure there's lots of questions. The only one I'll ask really is just to clarify again. Like I got up to the habitability, sustainability point, and I asked you to expand that out. So there are two questions emerging from that, and I think in your response about what sustainability is, it seemed to me that the current model of environmentalism, certainly at the policy level, follows a sustainability model, right? So it's essentially, let's keep going as far as we can and hope that the next generations can continue enjoying all the benefits of the terrible system that we've inherited already, which is again very human-centered. So there seems to be something very immediate about habitability as another approach to thinking about environmentalism, this eco-ethics, let's call it, or maybe eco-politics at this point, because it's not like the COP process. It's not COP thinking. And partly because COP thinking is like start from the benefits of inherited economic systems,
Yes.
and then see how we can keep these going. And there might be some degrowth in that, but actually degrowth is like, let's not go as far as we have, but kind of just keep things like more or less sustainable into the medium term.
Yes.
But there seems to be something much more demanding around habitability.
There is something demanding, at least in several ways. The first demand is what is the initial point of reference? Like, is the initial point of reference, do you still hear me?
Yes.
Yeah, I wasn't sure whether the microphone is still working. The first point of reference is, let's say, what is the lowest common denominator of the agents that are relevant in the given framework? Like, is it political agency? Is it an ability to speak? Is it an ability to follow rules? I think that the agency that has to be recognized at the basal level is just the agency in the sense of being able to metabolize and, let's say, circulate chemical and biological processes, matter and energy. So in this sense, we as humans don't matter that much as economic or political agents, but as biological agents. And in this sense, biological agents, I mean really bodies. Like, we need to come back to the understanding of a human as a body. And I think there's actually something really beautiful in how this line of thinking is meeting some of the thinkers such as Sylvia Wynter, for example. Because Sylvia Wynter is actually talking about, like, there is the mythopoetics of like narrating what does it mean to be human, but then she's talking about the genres of being human, but then there is also the bios, the kind of like the story of the human as a living being. And this life is not only life in the phenomenological sense of the life that is worth living, because there's a certain meaning that is invested into this life project, but there is also life in the sense of being a biological body and being a body that is affectable by the external circumstances. As that's the lowest common denominator from which the politics of habitability actually comes. And that's also, let's say, a unit of measuring and understanding agency that, in a certain sense, you are not going to be possible to arrive at this as a reference point if you start with the economic agent, and this is standardly modeled in the political economies of the 21st century. And also of much of the 20th century in this sense.
Okay, so I guess this is the second question I was coming to, which is that if it's about a general habitability seems to be tied with the generalized notion of ecology, and I think that's what we mean by substrate-agnostic, right?
Yes.
But the body then doesn't have to be an organic body.
Yes.
It can be a technological body.
Yes, because there is, if you look at the contemporary astrobiology, there are different attempts to expand the notion of life. There is, for example, Michael Wong and Stuart Bartlett with Sehe Chen and Louisa Tierney. They talk about so-called life with Y. So it's like life, yeah, or like life. Simply, it's life, but it's life in the sense that it's anything that has some kind of like a information driving force, chemical driving force, and the energetic driving force. And they are constructing hypothetical organisms in those papers that can fulfill these criteria, but are not based on Earth terrestrial substrates. For example, they are not based on carbon, or they are not based on the liquid water as the main driver of chemical recombination. So in this sense, I mean, the generosity, and that is actually a certain kind of generosity which is implicit in these new notions of life. It's a kind of generosity that, again, it invites a certain kind of normative attitude here.
Okay, I've got a couple more, but I don't want to go into. Can I just check if there are questions? It's a question. Can you just wait for the mic to come over? Just so we can get you on the record. Can I just see, are there any more questions? There's one here, one over here. All right, so go ahead.
I was wondering then, kind of connecting to the fact that it doesn't have to be organ matter to be life, considered life. I was wondering because now the kind of connecting to Boston Dynamics and AI, generative AI type of situation, large language models, they bring some sort of impact to the planet itself, whether it's the consuming of water or resources, and it kind of brings to the question, which is, what if the decay of the planet generates a new type of life that doesn't have to be organic?
Yes.
And it's this kind of like notion of technology being so advanced that it merges with nature, or it's unrecognizable with nature.
Yeah.
Is it worth that push, or is it like, because then the ethics of all that is what concerns me.
Yes, that's a really good question, because it relates to like whether I'm talking about necessity or about some decision to be made or that has been made. And I feel that it's as if we were in the middle of the loop, and in a certain sense to make the full arc means to actually sort of like undo, in a certain sense, the sin of starting that loop. And this is very Christian, I know, like, because I guess like there is a certain eschatological template that I follow here that is related just like to my upbringing in the Eastern Europe. But I think that also is really interesting if we think about it as simply we are recognizing let me put it this way. Technosphere, when it is usually defined, it is defined as some kind of like a major transition, as something new and radical that happens to the planet. But I would really like to see the technosphere and technologies as something like a scaffold for the continuation of the biosphere. Not in the sense of like technologies becoming the ultimate life support system, but technologies as something that is a transitory phenomenon which later falls back. Not in the sense of degrowth, but in the sense of, let's say, the continuation of the evolution towards finding the new equilibrium. And the kind of the resilience, I would say, template as, I don't know, some of the ecologists of the 1970s and 80s were talking about resilience as the ability of the ecosystem not to bounce back to the harmony state, but to actually kind of like traveling to the new valley of equilibrium from that valley that the given ecosystem was pushed out from.
Some sort of readaptation.
Because if we think about technologies, not just human technologies, but technologies that, for example, we see in the context of other species, whether it's ants or beehives, these are nice examples of a certain kind of like artificializations in the context of other life forms. We see that this is niche construction in the sense of like bidirectional adaptation, an adaptation of the organism to the environment, but also the adaptation of the environment to the organism. So adaptation as construction, and then also construction not as corruption, but construction as a productive unfolding of the environment.
So I just had a thought that just might help clarify this. So I think from the example of the beehive, like we as humans consider as nature because it's non-human, right? But your argument sounds like it's saying, actually, animals already do quite a lot of technological construction themselves.
Yes.
We just don't want to recognize it as such because of human exceptionality stuff.
So
we're just to finish the point. So we're already in a kind of there's a natural technosphere that we've really disregarded as technologies because we think technology is something that humans make.
Yes.
So it's already in place, and it's actually the problem is actually the humans not recognizing that we have human privileges or whatever on the basis of this bio-techno sphere. So basically your substrate-agnostic ecology.
Yes.
It's what nature already is anyway, right? The animals are already doing it.
Uh-huh.
So Beavers are building dams, that's a technology. Bees have beehives, that's a technology. I mean, it's happening everywhere.
Yes, but also I believe that technology is a little bit clumsy concept in the sense that it's a concept that a certain species uses to evaluate whether other species has it as well or no. Yeah, it's kind of like it's a category which is like a yes/no. There is either technology or no. I mean, the one way how to solve this is to simply think about technology as something that's more a matter of spectrum or a matter of scale. But also, I believe that any notion of technology, whether human or non-human, will be always tied to the given species, which is doing the judgment about is this technology or no. But something else happens when we think about concepts such as life, because life is a concept which, I mean, we see that the given species is life, and it's kind of like an undisputable, let's say, undisputable bedrock on which any other assessment of the capabilities of like the agency of the given entity stands on. It's either life or no, but life is a very generous concept in the sense that it is not like intra-species, but it's inherently interspecies. But technology or intelligence, I think there are more like intra-species discourses. Yeah.
Hi, I was just thinking about the question of scale. So as we were talking about cosmology, astrology, and its relation towards the ethics of ecology on Earth, and thinking about habitability and metabolism, there's this temptation of thinking about things at a massive scale, basically. And I was thinking about how do we implement that kind of philosophical thinking on a sort of individual relational level. I mean, without implementing that on a smaller scale, we're never going to be able to make a change. So I was just thinking about, the question of scale. Thank you.
Thank you. That's a really good question, because the scale is something tempting, as you say, in the context of planetary, that the planetary always invokes the large scale, the view from above, etc. But in one of the essays that I have written a couple of years ago, I have written that the planetary is hidden in the every grain of sand, which means that you can unpack like any parcel of land, for example, and you find relationalities which transcend the given parcel of the soil. And in this sense, human body is also a wonderful index of the planetary, in the sense that we, in the certain sense, embody and inhabit the planetary by the very fact that we are biological bodies, and that we are capable, not capable, but it always comes as the force of nature, in the sense that we cannot undo these basic metabolisms that sustain us, that we breathe, that we eat, that we sleep, that we exist in a certain circulation of biological and chemical material, including microbes, including viruses, and so on. And these are the moments in which really the planetary enters the optics of the human body, in the sense that I find very, very interesting to unpack further, because it is the sense in which the body is something that is a little bit selfless, in the sense that the subject comes as an afterthought of the embodied existence of the Homo sapiens. It's not the primary thing that makes humans humans, that there are selves, that there are subjects, but that there are bodies. Mm-hmm.
There's a question here.
Thank you, Lucas.
Thank you.
Kind of head exploding. And this may be the same question in different words, but I was really struck by the L, the long L, and this idea of how do we maximize the length of live planets, and joining that up to sustainability versus habitability. So I kind of understand, I think we generally do, what the policies are about sustainability, things like slowing down or stopping deforestation. What is the solution space for habitability, sort of as distinct from sustainability thinking? I can't come up with something top of my head, but where is that? And it's very ambitious. We've done such a bad job on sustainability. There's an even more ambitious concept. Seems a bit fraught as well.
Can you say what you mean by solution space?
Well, what should policymakers be doing if we want to maximize L?
Okay. I'll start with thinking like one example is example of what is, how do we reframe something as simple as nature conservation. Nature conservation, for example, is a certain approach to, let's say, it can be a solution to maintaining or sustaining biodiversity. It can be, for example, about maintaining resources, because, for example, there is, let's say, a place that's been stripped of all the vegetation or of all the, for example, wood that was there, and there is a need to regenerate the given resource from kind of like a sustainability perspective I'm speaking now. But nature conservation comes with a little bit of like a strange, like an optical trick. It kind of like presumes that there is always something that can be, let's say, preserved as it is without any sort of like further disruptions. That is a kind of like an idea that a given piece of land or a given piece of forest can be simply conserved and sealed from all the external relationships. And in this sense, I think that nature conservation misses the point of the fact that actually any sort of maintenance of nature is actually a construction of a certain kind of artificial nature, in the sense that even if we, for example, consider the given locality a national park, it's going to be by force of a certain artificial imposition, such as, for example, the legal substructure that will be able to maintain a relative stability of the given area. What I'm trying to point at is that the mindset that I think is the space for intervention in the context of politics of sustainability is the mindset when actually we take on the idea that maintaining nature is actually the project of constructing nature in a certain sense. That, for example, means that it may be reasonable to do such things as testing, for example, genetically modified corals. Is it a good idea, for example, to help the corals to still be in the environments of more acid and warmer oceans? Perhaps. I mean, I think like a certain, let's say, approach to the artificialization of the nature, in the sense that it makes sense, for example, to think about synthetic biology as a technology, but at the same time, synthetic biology is the continuation of the nature by other means. I mean, this would be one of the solution spaces, to think about policies that look at nature as the problem or the question, through the problems or questions of maintenance, not in the sense of conserving, but more in the sense of maintaining as constructing, just in the same way as any maintenance of a building is the continuous construction and the reconstruction of the building. So to me, as a philosopher, the maximum I can do is to do this philosophical lens grinding, yeah, to kind of like polish the optics of the people who are going to formulate the policies of tomorrow. Yeah.
So could you just check if there are more questions? There's one over there. But while the microphone travels up to you, so the consequence of that is the basic demand, I guess, would be something like you've got to keep metabolism going, right? Because planets are just metabolizing. To be a planet, you have to metabolize the solar system. Well, you need a sun. You need to metabolize the cosmos to get to a sun, which then gets metabolized to a planet. And planets are then like one particular localization of metabolism.
Yes.
And then once you're in the planet, you metabolize. So if you're doing...
Keep digesting.
Yeah, so if you're doing conservation, you're kind of asking, you're putting a cap on metabolism.
Yes.
But the immediate political consequence, and I think the difficulty of this in terms of the current sort of political thinking space or something, is that you then have to endorse a certain type of extractivism.
Yes.
And also, given the kind of technologies you're talking about, you have to endorse a certain type of corporatism, because that kind of technology cannot be implemented without something like state corporate entity.
Yes.
So, like, it sounds great, but I was thinking of Terminator scenario in this. Where the backstory of the Terminator is, I mean, this is my version from what you said, is the machines are going like, hey, metabolism, it's all like Boston Dynamics are kind of like, you know, we want to keep
habitability going, and you humans are just interested in sustainability in yourselves.
Yeah.
Well, the thing we need to do is get rid of the humans.
But the logic of habitability actually prevents it to the extent that you cannot point at one form of life to be the ultimate cause of the harm for the rest of the planet.
Ah, okay.
Because I mean, you would be actually you are suddenly dividing the space of like agents that are collectively responsible for the habitability between this life form that is making trouble and the rest of the biosphere, which is kind of still okay without the given species.
All right.
But in this sense, I mean, if we don't think about like history of ecosystems as something that is a history of one species kind of like making it and the others adapting, but if it is really about collective fine-tuning of parameters of habitability, then there is never going to be a possibility of, let's say, like pointing a finger at that one entity which is causing the trouble, which at the same time I think raises concerns in terms of political economy and the kind of corporate logic that you are pointing at. Like, that's an open question for me, actually. Like, what is the exact coordinates of the political economy of this kind of planetary metabolisms? We are trying to formulate something like an early draft with Adam Frank in that paper that I briefly mentioned on the planetary as, let's say, the political economy from the astrobiological perspective. But again, as far as we got was at the moment that it's not definitely going to be about, let's say, world governance, or some kind of like planetary enforcement institution that's kind of going to wholesalely impose certain limits on the life of individuals or societies, and that's it's less a stipulation and more actually a consequence of the fact that the planetary is not about scales of global versus local. The planetary is about processes that kind of like permeate through all these dimensions.
Okay. So my main takeaway is that habitability is how we stop Terminator scenario.
Yes. Okay.
Cool.
Yeah.
But
I like the keep metabolizing kind of like a slogan as well. Yeah.
So maybe last question over here.
I was just curious. I saw on the slide very quickly you mentioned the Gaia hypothesis, but not then, but a bit flash up. And just like in terms of the planetary, I guess I'm kind of wondering, your thoughts on that, like where you stand in relation to that.
To Gaia hypothesis.
Yeah.
I like Gaia hypothesis as one of the artifacts of the early, let's say, application of the idea that economy or that ecology is applied astronomy, in the sense that Gaia hypothesis was originally an astrobiological hypothesis about whether there is life on Mars. Before it became, because Lovelock originally formulated with Lynn Margulis the Gaia hypothesis when they were thinking about what would be the biosignatures of possible life forms on Mars. And the main idea was that there would be a chemical disequilibrium. There would be an active circulation of certain chemical substances in the atmosphere of Mars. So by looking at the atmosphere, we would be able to tell whether there is life on Mars or no. And then, by extension, by actually doing a certain kind of comparative planetology, they applied the same hypothesis on Earth, saying that, of course, there is chemical disequilibrium because there is life, but this kind of life is going to be the biosphere at large, not a particular form of life, because the biosphere at large has, let's say, an effect on the very external, or not like an external, but it has an effect of the structure of the planet itself. It's a different planet because there is life. There is not just a life which is dwelling in the craters of the planet, but it's a life that is capable of actively terraforming, in a certain sense, the planet.
I think, and that's kind of what I was going to ask you, is to, how much is that an integrated paper for you? Because I understood one of the criticisms of the Gaia hypothesis being that if all of our purpose was to create the Earth, that it puts us, the idea of sort of auto police, whatever the parts of the thing are there to make the thing. But that sounds like what you're talking about when you're saying habitability, and that our job is to make nature which makes us. So is there a kind of, are you kind of going forward into that place where the planet becomes a body and planetary consciousness can feel a thing, stuff like that?
I don't think that for example, one of the assumptions of like the stronger Gaia hypothesis is that planet is an organism in some like important sense, or like a superorganism. And I think the limit of this metaphor is that organism is probably not a right category to be used at this scale. Certain categories belong to certain scales, and my argument here is that at the level of a planet, an organism would have to be way more integrated system than just a system that is capable of, let's say, creating planetary effects such as the change of the atmospheric composition, which happened, for example, with algae, like, what was that, like 2 billion years ago or so, and it happens, for example, today in a much more dramatic sense with humans emitting CO2 into the atmosphere for the past like 150 to 100 years. So, yeah.
All right. So, as you know, somebody was saying, like, completely mind-blowing talk. It's really like asking quite a lot of like changes in sort of expectations and kind of belief systems in a way. But I think you did it again. As you just showed with like, you know, great clarification and explanation. So, thank you again. It's a really good end to our series. Thanks.